Alright, on number 5, part A, we've got to solve by completing the square. So we know the first step is we've got to have the x squared and the x term on one side and anything else on the other. So we need to get rid of that negative 5, so we'll subtract 5 on both sides. And so we will get x squared minus 8x on the left. And 0 minus 5, whoops, that should be negative 5 there. Let me fix that. And so let's go ahead and complete the square now. So when you have a 1x squared minus some number times x, here we have minus 8x, we can complete the square by taking half of the negative 8 there, the coefficient of x. So again, we're going to complete the square here. And so we're going to take half of negative 8, and then we're going to square that. And that's negative 4 squared, which is 16. Of course, anything squared is always going to be positive. So we're going to add 16 to both sides. And so now on the left side, what we've created is called a perfect square trinomial. That means we can write this as a binomial squared, basically in its factored form. And this would be x minus 4 quantity squared. Again, we're getting the minus 4 from the minus 8 there. Again, that's what we took half of. So on the other side, we're going to get 11. Now I made a mistake. I'll have to fix this here. It should be 11. So let's see, what can I do here? Let's do that and put 11 here. Alright, and then now we'll have to take the square root of both sides. Again, this should be 11 in here. Whoops. Let me put that 11 in. And then we'll take the square root of both sides. Of course, when you do that, you got to do that plus or minus thing. And so on the left, we're going to get x minus 4. We know that when something's squared and then you take the square root, those operations undo one another, and we're left with just x minus 4 here. And on the right side, we're going to get plus or minus the square root of 11. Again, I need to fix that. Let's put an 11 in there. Now, to get x by itself, we still need to add 4 to both sides. And so in our final answer, let's see, we're going to get x on the left. And again, let me go ahead and fix that, and I'll make that an 11. And so our final answer is going to be 4 plus or minus the square root of 11. Notice I could have put plus or minus square root of 11 and then the plus 4, but we normally like to put a number on each side of the plus and the minus sign. Another thing to notice here is the square root of 11 simplified, because 11, first of all, is not a perfect square, and there's no numbers you can divide 11 by that are perfect squares. And so this is simplified. We're done. All right, let's move on to the next problem that we're going to be doing here. Number 9, we've got 2 problems here, 2 rational equations to solve. So we want to find the LCD here first, and there's only one denominator, so that's going to be our LCD. Notice our restricted value, the value that would cause our denominator to be 0, that would be 4, because 4 minus 4 would be 0. And so 4 is a restricted value. Now, let's go ahead and multiply each of the 3 terms here by x minus 4. So you always want to make sure you multiply, when you multiply both sides of the equation by x minus 4, you have to distribute that, and so each term ends up getting multiplied by your LCD here. So notice here my x minus 4s are going to cancel. I'm left with 16. And then I have plus 2 times x minus 4. There's nothing I can do, I'm just going to go ahead and write those next to each other. I'll multiply in the next step. Then on the right side, I'm going to cancel my x minus 4's, and I'm going to be left with x squared. And now this is quadratic because of that x squared. What we want to do is simplify the left side, and then we want to get 0 on one side. So let's do that. So I would distribute 2 times x is 2x, and 2 times a minus 4 gives you the minus 8. On the other side, you still have that x squared. And then we got to combine that 16 and the minus 8. So notice on the left, we're going to end up with 8 plus 2x, and that's equal to x squared. So we're still trying to simplify, or actually we've got everything simplified now. Excuse me. So what I want to do is keep my x squared positive, and so I'm going to get rid of the 8 and the 2x on the left. So let's subtract 8 and 2x from both sides. So notice on the left you're going to get 0, and on the right you're going to have x squared minus 2x minus 8. Now this is a trinomial AC method is going to be what we'll want to use to factor this. So we need two numbers that multiply to negative 8 that add to negative 2. So our, let's see, that's going to be 2 and 4. And notice we need to make the 4 negative. So 2 times negative 4 is negative 8. And 2 plus negative 4 gives you the negative 2. So since this is a 1x squared, I can go ahead and put those numbers in with an x. And we get x plus 2 times x minus 4. And so finally, let's set each of our factors equal to 0. And so we're going to subtract 2 on both sides there on the left, and we get x equals negative 2. On the right, we're going to add 4 to both sides, and we get x equals 4. Now here's where we got to pause and recall that we said that x can't be 4. So we're going to throw out the 4 as an answer, and we only have one answer. That would be negative 2. Alright, let's move on to B. So here, notice on the left side you have an x minus 4, which it's not multiply times anything. You have to treat that x minus 4 as a single algebraic factor. And then x minus 3 would be another. And now if you look on the other side, x squared minus 7x plus 12. One thing we found with this kind of problem is we ended up factoring that, and we get the same two factors, or the same two denominators we have on the other two. So if you factor that side with using the AC method, you actually get x minus 4 times x minus 3. And I'm going to assume that you can do that, and I'm just going to replace x squared minus 7x plus 12 with that. And so now that is my LCD. X minus 4 times x minus 3. So we're going to multiply both sides. Oh, I'm sorry, x can't be 4. Notice 4 minus 4 would make this have 0 in the denominator, so that's not going to be allowed. And of course 3 can't be put in here because you'd have 0 in the denominator. And so those are our two restricted values. So let's go ahead and multiply by our LCD. Again, each term gets multiplied by that. So when we multiply the x over x minus 4, the x minus 4's are going to cancel. And we're left with x times x minus 3. Then we have a minus. And then 15 times, well, let's see, the x minus 3's here are going to cancel, and we're left with just 15 times x minus 4. So really what we're actually doing here is we're going to distribute negative 15 times x minus 4. You got to be careful with this type of problem because you do have to distribute that negative 15 to each of those terms. On the other side, notice both of our factors are going to cancel, the x minus 4's and x minus 3's, and we're left with just the minus 2x. And so we've got now to simplify or clean things up here. So I'm going to distribute x times x is x squared. Minus 3 times x is minus 3x. We'll distribute the negative 15x, or negative 15 times x, and negative 15 times negative 4. That would be 60. And again, on the other side, we just still have negative 2x. We've got a couple of like terms on the left, so let's take care of that. So we get minus 18x plus 60. So finally, everything's simplified. We just need to get, since this is quadratic, notice the x squared term, we need to get 0 on one side, so let's add 2x to both sides. And when we do that finally, we've got this nice quadratic equation, x squared minus 16x plus 60 is equal to 0. So we need two numbers that multiply to 60 and add to negative 16. It turns out that 6 and 10 is what works. And so I'm going to go ahead and put those there. Notice they have to both be negative, so negative 6 times negative 10 is 60, and negative 6 plus negative 10 gives you the negative 16. And so let's go ahead and plug those numbers in. Again, this is a 1x squared, so we can just plug those numbers in. And so we're going to end up with 6 and 10. And notice neither of those are restricted values. Alright, let's move on to the next problem. Alright, so at this point I'll be doing 12 through the rest of the problems, although I probably won't get them all done on this video, so there'll be at least one more. So let's see, first of all, if we're going to complete the table here, we want to solve for y. It's going to make things a lot easier for us. So let's add 3x to both sides to get rid of that minus 3x term. And then we're left with just y on the left and 3x minus 2 on the right. Now notice 3x and a minus 2, we couldn't combine those, they're not like terms. But also I put the x term first. One thing we learned is that in general we like to have it in this form. We call it the Slope-Intercept Form. Not just here, but in other places this is a useful form for us. So let's go ahead now and plug in our x values. So the way that this works is we know there's infinitely many solutions to this equation, and we write them as points. They're going to have an x and a y value. And normally we can pick whatever x values we want, but they've actually chosen for us here. So we're going to first, well, I'm going to go ahead and write y equals 3x minus 2 on the right there, but let's go ahead and substitute in the first value, negative 2. We're going to get 3 times negative 6 minus 2, and that gives us negative 8. And so negative 2, negative 8 is on the graph. And then if we plug in 0, we're going to get 0 minus 2, and that's going to give us negative 2. So 0, negative 2 is on the graph. And then if we plug in 3, we get 9 minus 2, which is 7, and let me go ahead and plot that one on the graph. Notice all three of our points line up, so we know it's a linear equation because x and y are both to the first power, and we expect to get the graph of a line, and if we don't get 3 points that line up, we know something's wrong. So here we're good. Let's go ahead and draw the line. Again, make sure you're always putting an arrow and try to draw a nice straight line as much as you can. Let's move on to the next one. Alright, so on number 13 here, we're supposed to find the x and y intercepts to draw this graph. So those are two special points. What I like to do is draw a little xy table. And first of all, we have to find an x-intercept. And so we want to let y equal 0. That's how we find an x-intercept. So let's go ahead and let y be 0. And I'm going to plug 0 in for y in the equation. And so now when I solve for x, of course negative 3x plus 0 is just negative 3x. Let's divide by negative 3, and we're going to end up with 2. So 2, 0 is my x-intercept. So now I got to find the y-intercept. So we're going to let x be 0. So again, notice they're opposites. To find an x-intercept, you start by letting y be 0. To find a y-intercept, you start by letting x be 0. So x is 0. Let's go ahead and plug in 0 for x into our equation. And notice negative 3 times 0 is just 0. And 0 plus y is just going to be y. So you can see that y is just negative 6. So let's graph those 2 points, 2, 0 and 0, negative 6. And when you draw the line, it's going to look like something like that. All right, number 14. For each equation, draw its graph and indicate the slope. So let's see. For y equals negative 5, well, first of all, y is equal to negative 5 right there. In fact, that's a common answer that students will give. But we should get a line when we're graphing, because these are linear equations. We should get a line. In fact, we know with the special cases we get a vertical or horizontal line. If it's y equals a number, it's always horizontal. Now, sometimes students forget which way to draw the line. And there's another way you can do this. All you have to do is create a table and let y be negative 5 each of your 3 times. Again, we usually find 3 points. And we can let x be whatever we want. And if you plot those points, notice they're on the line. So if that's helpful to you, you can make a table. So on number or letter B, you're going to have a vertical line. And it's going to look like that at x equals 2. And again, you could make a table and choose your x values to be 2. Let y be anything you want it to be. And when you plot those points, you can see they're on a vertical line. So this is x equals 2 here. And down below, we have y equals negative 5. And so I'll just go ahead and write that down real quick. Oh, I'm sorry. I had to find slope. So slope of the first line, that's our flat line. That has a slope of 0. And look at the other one. It's vertical, and so that's the one that's undefined. All right, let's move on to the next problem. So on number 15 here, it says we need to find the slope and y-intercept. Well, we learned about the slope-intercept form, and if we put a line in this form, we'll know the slope and the y-intercept. So this is what we want to do, is solve this equation for y and put it in this form. So the first thing we want to do is get rid of that 2x term. We're going to have 3y equals negative 2x plus 3. And we need to divide by 3 to get y all by itself. We're going to get y on the left is equal to negative 2/3 x plus 1. So our y-intercept is, well, first of all, slope's negative 2/3, and the or 2 over negative 3. So what I had talked about before is when you have a negative slope, we could put the numerator, or make the numerator negative or the denominator, but you don't want both to be negative because a negative divided by a negative is positive. It would be different. Just to be consistent, I usually use the negative in the numerator. So normally I would start, well, actually, let me go ahead and write down the y-intercept here. That's just going to be the point 0, 1. Again, we always know it's going to be that number at the end, and that's our b in the formula. And so we start at 0, 1, our y-intercept. Notice I just highlighted those answers because we had to find the slope and y-intercept first. So now we're graphing. We start at 0, 1, and then we'll apply that slope of negative 2 over 3. So our rise is negative 2, so we're going to go down. Remember, slope is rise over run. And so we went down 2, and then our run is 3, so we're going to go right 3. And that puts us at that point 3, negative 1. And now I could go ahead and draw the line here, but I just wanted to show you that if I had started at the y-intercept, and instead I did a slope where it's 2 over negative 3, I would rise 2, and then I would go left. Since it's a negative 3, I'd go left 3, and I'd have a point there. And you can see it doesn't matter which way I go. Either way, I'm on the same line. So again, you only need to find 2 points. Well, start with your intercept and find one more point. But I just wanted to show you that you could go either direction. Let's look at 16, and we'll call this the last problem for this video. It says determine the slope and y-intercept of the line and then write its equation. Alright, so first of all, the slope and the y-intercept, that makes me think of slope-intercept form. If I could find the slope and the y-intercept of this line, I could just plug the slope and y-intercept right into this. And so first of all, well actually we can do that quite easily actually. We know slope is rise over run, and we know we need to pick 2 points. So I'm going to pick these two right here. But let's go ahead and I'll go left to right. So we're going to do rise over run. So we're going to go down 2. That's down 3. That's -3. And then we're going to go right 2. And so that would be 2. So our slope is -3/2. The y-intercept, that's going to be right there, 0, -5, which means our b value is -5. So our y-intercept 0, -5. And so now we can plug those values in. Again, -5 is our b value. So we're going to have mx, so our slope is -3/2 times x, plus b, in this case b is -5. So we'll write -5. Alright, let's go ahead and stop here, and then I'll pick it up in the next video.